is Algebra 2, review 1 through 35. This is like part 4, something like that. Okay. All right, question 15. Question 15 goes a little like this, if I can find it. Not it. Here we go. All right, it's going to talk about the area of a rectangle. The area of a rectangle is equal to, let's see, let's find out what they've got here. Let's see. Okay. Okay. Let's try, let's see. X squared plus, what's our other part here? This is where this gets challenging. I'm going to hit pause here for a second. Well, we'll do our best with it. Let's say 132 over here plus, we got an X. Okay. Okay. Let's say the area of a rectangle is equal to that quadratic function. And we know that the length of, let's say the length equals, let's see, let's make it something else. Well, we'll leave it. Say x plus 12. We want to know what the width is. What expression represents the width? Thoughts? This one is a little difficult to try to come up with just a more random question. It's going to give you something similar to what's on the test without it being the test question. What do you do here? Divide them? Okay. So one method in here would be, okay, what do you mean divide them? What am I dividing by what? All right, so you want to take x squared plus 23x plus 132 and divide it by x plus 12, like that. Okay. All right, so how many times does x go into x squared? X times, right? What's the next step in solving if we're going to solve via long division? Okay, so x times x is x squared. You put that down here, then what? Multiply x times 12. What's x times 12? Where do I put that? Okay, so plus 12x. What do I do with those things? Subtract. Okay, what do I get? 11. 11 what? 11x. What happened to the x squared minus x squared? Canceled out. Okay, now what? Oh, here. Raven's here. Okay, I'm going to scoot you over here. Okay. Does that help? All right, now what? Bring down the 132. Okay. Now what? plus 11 because 11 times x is 11x. Okay, so bring that down here. Okay, what's 11 times 12? Okay, so bring down 132. Okay, what happens next? They cancel out. Okay, which means do I have what kind of remainder do I have? So what's the width? X plus 11. Okay. There's another way to do that. Okay, what way could we also do this? Put the long one, just factor it. So what you're saying, like just do this. Just do like this, plus and plus, right? But I still have to find, I've got to find basically the numbers that are multiplying to be 132 but add up to 23, which we would get 12 and 11. No, what I'm talking about is do exactly what you did with the long division, except use synthetic division. So I would put 1, 23, 132. And I would set x plus 12 equal to 11, or sorry, x plus 12 equal to 0, right? And subtract 12, right? So I'd get x equals negative 12, put negative 12 here, bring the 1 down. 1 times negative 12 is negative 12. 23 minus 12 is 11. Negative 12 times 11 is negative 132, which gives me a 0 remainder. And if that was x squared, this is going to be just x plus 11. So that's another way of showing it that's maybe a little less complicated in terms of what I have to think about. Still gets me x plus 11, right? Let's see. I want to see on this. Okay. All right. Let's keep going. But that's the work that I need to show. 16. 16. I want you to tell whether the graph of a quadratic function opens up or down and to explain. All right, so if I have something like y equals negative x squared plus 7x minus 23, does that graph open up or down? Down. How do you know? Okay, down. Down is correct, but you have to pick an explanation as to why. Why does it open down? How do you know? Right, but the position of this, all right, the quadratic function is ax squared plus bx plus c. The answer is because the a is less than 0. If the a is less than 0, it opens down. Okay, the coefficient for x, which is that a, is less than 0 because the coefficient is negative 1, right? Okay, so if we had something like y equals 3x squared minus 29 plus 42, which direction would that open? Up, because a is greater than 0. Okay, does that make sense? All right, and you guys know what I'm referring to whenever I say a, right? The coefficient to x squared is a. And that's what they're going to talk about in your explanations. Okay? So it's going to open upward. Okay? 17. Okay, 17, we want to determine whether the relationship is an inverse variation. Okay, so we're going to get a table of values, and they're going to also ask you to explain. Okay. 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 All right, so let's say we had 1, 2, 3, 4, 5. Okay. Let's say 150. Okay. Go 305. No, hold on. Um, okay. Is that an inverse variation or a direct variation? Okay. So inverse variation, can you explain why?
Because as x increases, y decreases.
So this is going up as it goes, and this is decreasing as it goes, right? Okay. So inverse variation, do we agree with that? That answer is incorrect. You're right in making that your first assumption, but before we settle on it, what should we do? What does either a direct or inverse variation have to have? A constant, right? So I have to first determine, right? First, yes, we would plug it into the inverse variation equation, okay? But that's just the first step, okay? After that, what is the inverse variation equation? Y equals what? Raven, do you know? It's the inverse variation equation. Y equals what? K over x. That is exactly right. So if y equals k over x, how do I solve for k? Multiply x and y. So yx equals k. So how will I know for sure that this is an inverse variation? Well, yeah, y equals kx, and if I was going to find the constant there, I would take y divided by x, and that equals k. But that's certainly true. But what do I still have to check? You found the equation for inverse variation, but you haven't done anything with it. What do you still have to check? You still have to check to see if there is a constant, right? How many of them do I have to do in order to see if there's a constant? All of them, right? So I find a constant here by taking y times x. So what's 1 times 150? All right. What's 2 times 109? What's 3 times 76? 228. Okay, what's 4 times 53? What's 5 times 40? Is there a constant here? No, so it is neither inverse or direct. Okay? Does that make sense? Now, if all of these had come out to say 200, we would have said, yes, that's an inverse variation. But it wouldn't be enough to say it's an inverse variation. Your work would have to show me, okay, what the constant is. So we're going to say neither, no constant. And we've proved it. Okay? And that shouldn't be a terribly hard thing to prove. We're just multiplying two numbers 3 or 4 times. All right, 18. Okay. Now, this one's a little different. Um, okay, let's see. All right. Okay. Okay, so what I've got here is I've got a triangle. Okay. And this coordinate here is 1, 2, 3, 1, 2, 3. We'll say 3, 3. This coordinate down here is 1, 2, 3, 4, 5, 6. So it's 6, 0. Those 2 points determine our triangle with respect to the origin. All right, so then we want to enter those 2 points into a determinate matrix. Okay, and it's going to look like this, like x1, let's see, it goes x1, x2, y1, y2. Okay, it's a determinant, right? What we want to know is I want to know how does the value of the determinant relate to the area of the triangle? How does the value of the determinant relate to the area? So we have to do 2 things. One, we have to put in our x values and our y values into this determinant and solve the determinant. Thing 2, we have to find the area of this triangle. Okay? Doable? Hopefully. Okay, so as we bring this down, let's go ahead and let's do the determinant first. Okay, what was x1? What is it? 3. Okay, what's x2? y1? y2? 0. Okay, how do I find a determinant? A times D, so 3 times 0. Okay, so 3 times 0 is 0, right? What's negative 3 times 6? Okay. Okay, negative 18. All right, now let's find the area of the triangle. Okay, how do I find the area of a triangle? What's that? Base times height. What's the base? 6. Good. What's the height? 3. Okay, and then do what? Divided by 2. Okay, what's 6 times 3 divided by 2? 9. Okay, now, we got this here, we subtract it. Let me see what, okay. Now, let's consider this as like 18. Is that okay? Okay. So how does the value of the determinant relate to the area of the triangle? What was the area of the triangle? 9. So that's our first part of the question. Find the area. Okay? Now, what is the determinant in relation to the area? It's twice as big, right? Okay. The determinant is twice the area. Okay? So, what's that? Yeah. So make sure you read the question really closely on this, okay? Because they're going to tell you what they want you to list first, whether it's the determinant or the area. Okay, you make sure that what you have listed corresponds with what they're asking for first. Because it's really two questions. What's the area of the triangle, and how does the determinant relate to the area? Questions here? Okay. Are you good, Mia? All right, 19. All right, this is the last question. There's only 19. Okay. It's going to talk about two resorts. They're going to offer private lessons for their customers. Let's say the Big Mountain Ski Resort. They do theirs at, let's see. Let's say it's $10 per hour plus $50 in insurance. $10 per hour plus, let's make it $100 for insurance. Okay, it's Big Mountain Ski Resort. Okay, let's see, Powder Hills. Powder Hills charges $20 per hour. And $60 for insurance. So cheaper insurance, more dollars, more expense for class. Okay, we want to know how many hours are the lessons going to cost the same. How many hours are they going to cost the same? When will they be equal? $10 plus 100x. Okay. Would it be? Why is it 10x and not 100x per hour, per class even? The $100 is flat. Okay. Now what? Equals what? Plus 60. Okay, good. Now let's just solve for x, right? Because x represents classes. Okay, now what? Subtract 10x from both sides. Okay, so I got 100 equals 10x plus 60. Subtract 60 from both sides. Now what? What does that equal? 40 equals 10x. Divide by 10. So x equals 4, what is this? Is this per hours? Yeah, so this is hours. X equals 4 hours. That's your last question. All right, I'm going to stop all this. I'm going to try to get everything sent so you got it for tonight. You guys have really all day tomorrow to study, okay, and get prepared for Friday.